About that, video stopped accidentally. So, what I was saying was, for the 90 seconds and for 3 feet per second, what should we do to see how far he goes? So if we take these two numbers, 90 seconds, and we're going 90 seconds at 3.5 feet per second. So every second he's going 3.5. So we're going to take 90 times 3.5. And we get 315. So that's how far down he went. So he went down 315 feet. So going back to some stuff we did at the beginning of the year, is this a positive or a negative number if we're 315 feet below sea level, going straight down? It would end up being negative. Then he travels directly up for 30 seconds at 2.2 feet per second. So now he's going to go 30 seconds at 2.2 feet per second. So if we do 30 times 2.2, we get, going up, which is positive, 66 feet. So where is he now? What should we do to figure out where exactly he is in comparison to the top of the water at sea level? Well, since this one's a negative and this one's a positive, and we're looking to see where he is, we should add them. Negative 315 plus 66, and we get that he's at negative 249 feet. Is that our final answer? Is that what we were looking for? Let's go back to the question. So after the 120 seconds, which was the 90 and the 30, how much time in seconds will it take Mr. Montalvo to travel back to sea level at the submarine's maximum speed of 4.8 feet per second? Round your answer. So we know that he went this far, and we're going 4.8 feet per second. How long is it going to take him to get back up? So we know the feet, we know the distance, and we know the speed. How do we find the actual length of time? So what should we do? Should we add, subtract, multiply, or divide? I believe we should take the 249, divide it by the speed, 4.8, and we end up getting 51.875. So that's how long it should take them to get to the top of the water. But it says round to the nearest tenth. So if we look at the 10th place of 8, does the 7 change it or keep it the same? Yes, because it's above 5, it changes this to a 9. So it takes 51.9 seconds. Miss Jadu has $100 to spend on parking and admission to the zoo. The parking will cost $7, and admission tickets will cost $15.50, including tax. Write and solve an equation that can be used to determine the number of people she can bring to the zoo, including herself. That's kind of a big deal, that including herself. So she has $100, so we know that that's the total. Okay, so that's going to be the equals 100. The parking will cost $7. So if you think about when you go somewhere, how many times do you have to pay for parking? You only have to pay it the first time. So that's just going to be $7. Each ticket will cost $15.50. So if we were to say plus 1550 x, that's our equation. That's the equation you need to use to solve. So do the additive inverse, which cancels it out, and whatever we do to one side, we do to the other. So we have 1550x equals 93. So then what do you need to do now? Now that you have 1550x and 9 on the other side and 93 on the other side, what should you do? Yes, divide by the coefficient. And the coefficient is 1550. And once you do that, you get x equals 6. So it says, how many people can she bring to the zoo, including herself? So 6 total people can go to the zoo. So it would be 5 people and 1 Jadu. And that's our answer. So Harry bought 3 t-shirts and a belt for $69.75. The belt costs $22.50. How much does it cost for a shirt? So she bought 3 shirts. So that could be 3S. And she bought 1 belt, which costs this much. So we know how much the belt costs. We don't need to figure that cost out. So we know that he's buying something for $22.50 for this much. That's your total. So we do equals $69.75. What should we do first? We're looking for the S, so we need to get that by itself. So let's get rid of the $22.50. Subtract it from both sides. What happens here? They cancel out. They're inverse. So 3S equals, so we do 69.75 minus 22.50. And we get $47.25. Our last step is divide by the coefficient, which is 3. And we get S equals 15.75. And that's our answer right there. That concludes equations. Now we could move on to inequalities, which is very, very, very similar to equations, except it becomes, you need to remember to round logically. You don't round to the nearest tenth or the nearest whole number. You round to the nearest logical number.